continuation for finished product quality control for tablets. So after friability, we have your disintegration. Okay, so when we say disintegration class, this is the process by which your tablets disintegrates, no, or liberates, no, from the dosage form. So this precedes dissolution, no? So kung matagal si disintegration, then matagal ang dissolution. So disintegration should be under the specified or should happen within the specified time. So equipment, we have your basket rack assembly, which is composed of 6 cylindrical tubes with 10 mesh wire cloth, no, at the bottom. Sige. So, one thing to note is the temperature used in disintegration. So, in disintegration, we use close to the body temperature, no, 37 degrees plus minus 2. So, here, we perform 29 to 32 cycles per minute. So, anong meaning yan? No? Tataas and bababa ang basket 29 to 32 times per minute, no? So basically murag musaka munaog from the solution ang ating tablet, no? Within the basket. And then after that, after the allotted minute or after the allotted time, the end goal is an impalpable core. Ito class, very important. What do we mean by impalpable? No, what do we mean by impalpable? Merong may idea what is impalpable, no? So that a board exam question. Impalpable means no, not perceptible to the touch, no? So impalpable, not perceptible to the touch. No? So kung hahawakan mo siya, parang wala na lang siyang core na tablet. So meaning puro powder na lang dyan siya class, no? So from the tablet naging powder na lang. So dapat ganun lahat for the 6 tablets, no? So kasi 6 ang tubes, so 6 din ang tablets. So sa 6, if 1 or 2 did not disintegrate out of the 6 samples, then go to stage 2. So perform 2 trials more. So 2 trials more, 2 times 6, 12. So plus sa 6 sa stage 1, so 12 plus 6. So out of the 18 samples, kung may nag-fail pa, more than 2, then bagsak na talaga. No? Bagsak na siya sa disintegration test. So kung dito class, sa first stage pa lang, 3 na yung bumagsak, then wala nang second chance. No? So walang 2 trials more na. Okay? Ayan. So you have your disintegration. So again, take note of the number of samples, yung goal, at yung temperature. Next, we have your specifications for each of the type of dosage form. So we have your plain uncoated and sugar-coated and capsule. So mga conventional dosage forms. So acceptance criteria, dapat mag-disintegrate na sila by 30 minutes. Okay. So for enteric-coated tablet, pag enteric-coated tablet, saan dapat sila mag-disintegrate? No, pag sinabi nating enteric-coated, no, they are designed to disintegrate at what area of the body? Sige, anyone? Correct, no? Sa intestine, sa GI, intestine. No? So, this is in order for us to protect the stomach, no? So, for example, sobrang irritating ng drug sa stomach or nasisira ang drug ng acidity ng stomach. So, vice versa. To protect the drug from the stomach or to protect the stomach from the drug. So, ang ginagawa ng enteric coating, no, prino-protect siya from the gastric juice, tapos sa intestine na mag-disintegrate. So, for the disintegration of the enteric coated, no, lalagay mo siya sa distilled water for 5 minutes. Dapat hindi siya mag-disintegrate. After 5 minutes, ililipat mo siya sa gastric juice. So, gastric juice, this is simulated na parang sa stomach ng acidity. So, it should not disintegrate within the 1 hour And then after that, after 1 hour, ililipat mo siya sa intestinal juice. So, dyan yung ating intestine. So, after 1 hour or within 1 hour, dapat nag-disintegrate na. No? So, sa plain uncoated, distilled water lang, 30 minutes nag-disintegrate. No? So, sa enteric coated, medyo medyo matrabaho. No? So, from distilled water, 5 minutes. Sa stomach, 1 hour. Then, sa intestine na siya mag-disintegrate within 1 hour. Buccal tablets, di ba? Buccal are intended for slow release, no? Slow release. So, since slow release, the disintegration should be long, no? So, 4 hours, no? So, di ba sa buccal, gusto natin slowly ang pag-release ng tablet or ng drug from the tablet. So, matagal din dapat siya mag-disintegrate. Kabaliktaran kay sublingual. Di ba? Kay sublingual, gusto natin immediate ang effect. So, dapat mabilis ang disintegration. So, within 3 minutes. Ayan. So, meron din tayong tinatawag na class? Orally disintegrating tablet, no? Or ODTs. No, this is fairly new. No, so your ODTs, no, oral disintegrating tablet. So, anong meaning no? Nasa pangalan na, no? It disintegrates in the mouth, no? Using your saliva. So, usually class, this disintegrates with less than 1 minute sa saliva. Less than 1 minute. So, anong benefit nito? Anong benefit nito? So, you can, with this type of dosage forms, no, you can drink it without drinking it with water. No? Pwedeng walang tubig and you make sure no, na nasa swallow ng patient ang drug. Let's say example no for your antipsychotics no mga antipsychotics 'di ba minsan ang mga mental hospital patients mahirap silang painumin ng gamot or minsan 'di ba parang sa mga movies no ginadaya nila ang pag-inom sa ilahang gamot luwa nila no if hindi i-check. So for that no this is a good somehow na solution no or alternative no. So somehow dahil sa mouth mo pa lang paglagay mo pa lang sa mouth nag-disintegrate na siya, sure na matulon niya iyang laway so matulon jud niya ang drug no. So ayan, you have your orally disintegrating tablet. And lastly ito board exam question or board exam concept. Chewable tablets are never or are excluded from disintegration test. No? So, pagtatanungin, what is the disintegration time for chewable tablets? No? So, wala. Kasi chewable tablets are not tested. Bakit? Bakit hindi siya tinetest for disintegration, si chewable tablet? Bakit hindi chine-check or bakit hindi tinetest si chewable tablet for disintegration? Sige daw. Bakit kaya? No? Bakit siya exempted or excluded from disintegration test? Why do you think so? Okay. Di na need man go kasi sa mouth. Kaya disintegration kaya nasa. Sige. So, the reason is dahil wala siyang disintegrants. No? So, your chewable tablets do not have any disintegrants. Kaya, it's very important na pag chewable ang tablet, sabihin nyo talaga sa pasyente na i-chew or i-break talaga siya before swallowing. Kasi mahihirapan ang drug mag-liberate or matanggal or ma-release sa drug product. No? So for chewable tablets, example, 'di ba sila Bonamine, no? So sa mga drugs for or mga medicine for children, no? So dapat talaga i-chew or i-break before swallowing kasi they do not have any disintegrants, no? So yun yung reason, wala silang disintegrants. Okay, unlike other tablets. Okay, after disintegration follows your dissolution test. So for dissolution, no, this also affects bioavailability. So kung hindi ma-dissolve into aqueous solution ang inyong drug, then mahihirapan siyang ma-absorb ng ating katawan. So we have to make sure that appropriate amount of drug is dissolved. Okay? So apparatus, dissolution apparatus, medyo madami. No, medyo madami, but the most commonly used are the apparatus 1 and apparatus 2. So that's your basket or paddle. Okay, so the next other apparatuses, no? So para mas madaling matandaan, no, hindi natin ma-confuse itong mga reciprocating cylinder, revolving cylinder, reciprocating holder. So tandaan na lang sa in terms of the first word, no, sa reciprocating versus revolving na cylinder, isipin nyo na lang alphabetical order. Sorry. So mauuna si reciprocating versus revolving cylinder. And then after that, you have your reciprocating holder. So same also, alphabetical order. So mauuna si reciprocating cylinder bago reciprocating holder, no? Para hindi nyo siya ma-interchange. Okay? So nakalagay dyan, apparatus 5 and 7 is used for TDDS. So what do we mean by that? Your transdermal drug delivery system. So for transdermal drug delivery system, we use apparatus 5 to 7. But yun na nga, pinaka-common ginagamit natin is still basket and paddle. Okay, so anong mapapansin natin sa temperature ni dissolution test? Mas strict siya, no? So mas strict siya. 37 plus minus 0.5 degrees Celsius, no? So mas konti or mas mas strict siya sa conformation to that body temperature, no? So kanina kay disintegration, 'di ba, plus minus 2. Kay dissolution, plus minus 0.5. Okay, next. Upon dissolution test, no? So, sa dissolution test class, ganito ang mukha niya. No? Bali, 6 na parang big cylinder, tapos merong paddle. So, kung paddle, mura siya ana. So, kani siya mag-rotate na siya class to dissolve the tablet. So, nadali mo tablet. Okay, so after the dissolution test, kukuha tayo ng alico midway from surface of the of the medium, which is 1 centimeter from vessel wall. Bakit kaya doon tayo dapat kumuha ng alico or alico? No, so basically what you will do, no, magpapipette ka dito. Papipette ka dito. Midway from surface of the medium, 1 centimeter from the vessel wall. Bakit midway? Bakit hindi sa top or bakit hindi sa bottom part? No, why do you think so? Bakit kaya gilagay talaga dyan na dapat doon tayo magkuha ng aliko? Sige, why do you think so? Ano kaya ang reason by doing so? Para po mas precise, no? So correct, no? So the most accurate or precise concentration is located or somehow in your midway, no? Kasi kung dito ka, pwedeng very low ang concentration or very diluted, no? Diluted. Kung dito ka naman sa dulo, baka sobrang concentrated. No, very concentrated. So the most accurate is sa gitna. No? So the most accurate point of getting the concentration is sa gitna. So basically class, 'di ba, pag nag-dissolve na si tablet dito, so na siya sa solution. So na siya sa liquid form or aqueous solution. So pipette ka diyan ng certain amount tapos i-HPLC mo siya or i-UV mo siya para malaman mo yung concentration niya. Okay? And by then, that is your Q. You compare that to your Q. Okay, so next we go to this table. So what is Q? No? So, Q is your labeled percent. Ayan. So, labeled claim. So, for example, si paracetamol daw class contains 500 milligram. Okay, so, labeled claim of paracetamol is 500 milligram. Tapos, ang Q niya ay 90%. So, meaning, dapat dito, so dito sa first stage, no, each unit is not less than Q plus 5%. So, hindi dapat bumaba sa 95% ng 500 milligrams ang content ng inyong dissolution test na result. No? So, pag compute mo sa concentration ni tablet, sorry for that. Okay? So, if ang concentration dapat ni tablet of the 6 samples or 6 tablets, it should not be less than 500 times 95%. So, dapat 95% times 500. So, dapat hindi bumaba sa 475 milligram. No? So, pag may bumaba dyan sa 475, so, you add 6 more. No? Sa stage 2, add ka ng 6 more. So, 12 na ang inyong sample. So, average of the 12 should not be equal to or greater than Q. So, dapat ang average ng lahat ng tablet na concentration should not be less than Q. No, dapat mas equal siya or mas malaki pa sa Q. And then walang unit na Q minus 15%. So what is Q minus 15? So 90% minus 15, so that would be 75. No, 75%. So, dapat 75% times 500. So, dapat walang bumaba sa 375. No? Kung may bumaba pa sa 375 milligrams, then proceed to stage 3. So, dito class, sa stage 3, may tatlo ka ng requirements. No? So, no more than 2 units are less than Q minus 15 and no unit is less than Q minus 25. So, take note, these are all co-conditional. So, meaning, dapat naka-end yan. So, dapat all of the 3 characteristics or acceptance criteria are satisfied para masabi mong pasa siya. No? So, dapat check ito, check ito, check ito. No? So, para masabi mong pasa. If any is not satisfied, if any of this bagsak ang inyong product. No? Bagsak inyong product. Okay. So, ayan. That is for your dissolution test. Okay. So, next, for your capsule. So, for your capsule class, we also do disintegration. Kanina, di ba, pag plain capsule, 30 minutes siya. Sa dissolution, depende sa inyong capsule. But we still do perform dissolution test for capsules. And then next, for content uniformity. Remember kahapon sa tablets, no, sa uniformity of dosage units, 'di ba, sa tablets kahapon, pag less than 50 ang active ingredient, unsa gani ang i-perform sa tablets kahapon, pag less than 50 milligrams ang active ingredient, ano ang ipe-perform for uniformity? Sige, ano ipe-perform for less than 50 milligrams of active ingredient? Sige, ano ang ipe-perform? Sige, manawag ko. I-discuss natin yan kahapon. Sige, let's have Hashena Pertimos. Hashena. Wala. Sige, let's have Grace agad. Wala also. Sige ha. Castillon, Eloise. Okay, wala pod. Erica Bucalon. Erica Bucalon. Wala also. Solania Althea. Okay, so less than 50 may sumagot na. So tama, content uniformity. Pag greater than 50, okay, you have your weight variation. You base on the tablet weight, correct. Ayan, so pag if less, yes, content uniformity. Now for your capsules, pag less than 25, content uniformity. But if suspension, emulsion, or gel ang nasa capsule, then ang basis mo ay greater than 25. Okay? So for capsules, 25 milligrams ang ating basehan. Pero pag suspension, emulsion, or gel, pag greater than, doon ka magko-content uniformity. No? Kabaliktaran, weight variation. No? So for weight variation greater than 25 and kung solution ang nasa loob ng inyong capsule. No? Kung solution ang present sa inyong capsule. Okay, next we have your semi-solid dosage forms. Ayan, so semi-solid dosage form. So this includes your pH. Ayan. Sige. Why do you think kailangan i-test si pH for semi-solid dosage forms? Like your ointments, creams, no? Sige. Bakit natin kailangan i-check ang pH for your semi-solid dosage forms? Sige, Kablinda. Sige, Mangano, praised her hand.
Sorry po, ma'am. Nakuan po, ma'am. What is the question po, ma'am?
Why do we need to check the pH for your semi-solid dosage forms?
It's because, hello, it's a ma'am na. Nawala ako ang kuan. Akong notes. Yeah. Wait mo na, ma'am.
Sige, Miss Mangano praised her hand. Ikaw na lang.
For me, ma'am, kailangan i-test ang pH kasi topical po siya, ma'am. So it means na i-apply siya sa surface ng skin po, ma'am.
Okay, and bakit, ano palang effect ng pH? Sa skin.
Baka mag-irritate po ang skin, ma'am. Kung
Okay.
kung acid or sobrang acidic or basic ang dosage form.
Very good. So, ayan, you have your topical preparations, no, applied on the skin, and it should conform or somehow be close to the pH of the skin, no? Ma-maintain yung pH ng skin or hindi niya ma-irritate yung area ng skin. Okay, correct. Or, ayan, so, stability could be, but it should mainly on the physiological pH, no, of the area of the skin applied. Okay, ayan, you have spreadability, no, for ointments and creams. spatula fill, and melting range. Ayan, melting range. Sa aling semi-solid dosage form, very important, si melting range. Ayan. So, at what or in what type of semi-solid dosage form? Important si melting range. Sige. Nathan, atensya.
Hello ma'am, audible po ba ako?
Yes.
Sa akin po ma'am, sa cream po siguro kasi kung mabilis mag-melt yung cream, pangit yung parang skin feel niya.
Okay. Sige, any other answer? Sige, Sheila.
Suppository po, ma'am.
Okay. So, correct, no? So, your suppositories, di ba? So, your suppositories should have a sharp melting point or melting range, no? Di ba? They should melt near body temperature, but they should remain solid sa room temperature, no? Solid siya pag nasa botika lang, pero pag nasa body temperature na, doon sila dapat mag-melt, no? So, to control the melting range, no? So, ayan. And then lastly, of course, we have your microbial content. Okay, so microbial content for oral or topical products na non-sterile. So pag sinabi nating non-sterile, pwedeng may present na bacteria, pero within limits. No? So non-sterile, so we have presence of aerobic bacteria. So we use your tryptone soy agar. For yeast and molds, no, for fungi, we use your potato dextrose agar. And specific bacteria, we have the specific media. No? So, just to check if may mag-grow, then tingnan natin kung below siya sa limit or acceptable pa ba siya. No? The number of bacteria present. Okay, next, we have the minimum fill. So, minimum fill class, it just tells you na kung how much yung nasa label is yun talaga yung present sa lalagyan mo, no? So let's say ang nasa label ng cream, it has 150 grams, no? So dapat yung content talaga ng container is 150 grams. So that is just the goal of your minimum fill, no? For creams, gels, jellies, lotions, ointments, pastes, powders, and aerosol. No? So for correctness of labeled amount or content. Para din true to the label ang ating content. So sample size, we test 10 initially and then retest on 20 containers. So basically class, what we will do is scrape natin lahat ng, we weigh the container plus the sample or plus the product. Tapos tatanggalin natin yung product, tapos ima-minus natin yung weight. No? So dapat mag-equal yung difference sa ating labeled claim. So bale, i-weigh mo siya na may product, container plus product, minus weight ng container lang. Para somehow ma-check mo kung how much talaga na product ang present. Okay, next, ophthalmic ointments, no? So for ophthalmic ointments class, it must be sterile. Bakit kailangan sterile? Single use, it must pass sterility. Kasi 'di ba, we apply the ointments on our eyes. So sa mata siya ginalagay, no? So syempre dapat hindi ka maka-introduce ng bacteria sa mata as it may cause infection. Pag multiple use, pwede naman. But pag multiple use, always dapat meron tayong bacteriostatic agent or meron tayong preservative na present. Okay? So the number of particles, in all 10 tubes. So sa 10 tubes, lahat ng particles na present, i-add mo lahat and should not exceed 50. No? It should not exceed by 50. And dapat sa 10 na tubes na to, walang tube na lalampas sa 8 ang particles na number. No? So, dapat 7 lang, 6, or less than 8. No? So, note, naka-end yan ha, naka-end. So, dapat ma-satisfy niya yung dalawang criteria na yon. No? So, sa 10 tubes, hindi mag-exceed ng 50. Tapos, walang tube na lalampas ng 8 ang particles. Okay, and then we have your liquid dosage form. So, liquid dosage form, so we also check the pH, the appearance, the color, odor, and taste, no? So, of course, di ba, the color of the syrup should be parallel to or correspond to its flavor, no? Or the odor and the taste, no? So, for example, strawberry flavor ang syrup. Of course, expect natin na color pink at amoy strawberry. Then we have deliverable volume. So, sa deliverable volume class, somehow same lang siya kay minimum fill. So, let's say, ang sabi sa syrup, it contains 60 ml. No? So, same lang po. No? Dapat yung bote, 60 ml talaga yung laman. No? So, next, chemical. So, presence of degradation products and potency. Okay, next, for suspensions, we have your sedimentation volume. So, it's a simple ratio of the height of the sediment to the height of the initial suspension. Sige. So, ano ba ang gusto natin? Mas maliit na sedimentation volume or mas malaki? No? So, what is for an ideal sedimentation volume? Or SV? So, we would want closer to 1. No? Closer to 1. Kasi pag 1, no? The sediment, walang sediments, no? It is equally dispersed, no? So, meaning, kung 100 ml siya, after some time, 100 ml pa rin, meaning hindi siya nagsettle sa baba, no? So, the ideal sedimentation volume is equal to 1 or 100%. So, meaning, nakadisperse 100% ang ating particles. No? Hindi gaya dito, no, after some time, nagtipok na lang ang sediment sa baba. Okay. Sige. So, bakit gusto natin equally disperse ang ating sediments or ating suspension? No? Ayaw natin siyang settle sa baba. No? What is the risk if nagsettle ang ating suspension? What is the risk for suspensions that settle easily? Sige, Mission.
Para ma-make sure po na same amount of the active ingredient ang ma-dispense or yung mainom ng patient po. At saka may tendency po na baka yung sa pinakababa ang mabigay, then baka mag-overdose or something po.
Okay, very good, no? So, kung sa taas ang kunin, underdose. Kung sa baba din, overdose, no? So, to have uniform dosage, you have to have a uniformly dispensed suspension, no? Kaya, di ba, sinasabi natin talaga sa patient, i-shake well before using or i-mix muna bago gamitin or inumin. Okay, so yon, your ideal sedimentation volume should be 1 or 100. Next is the degree of flocculation. So that's the sedimentation of a flocculated versus the sedimentation volume of the flocculated system or suspension. So you have your degree of flocculation. Sige. So, anong gusto natin or what is the benefit of flocculated versus deflocculated? Pag sinabi nating deflocculated class, wala lesser ang kanyang tendency na magbuo-buo. No, pag sinabi nating deflocculated, lesser tendency na magbuo-buo. Pero, pag nagsettle na siya class, lisod na siya ipabalik sa original suspension. No? So, sa deflocculated, evenly dispersed, hindi nag-aggregate ang powder. Pero, pag nag-aggregate or nag-settle na siya, mahirap siyang ibalik sa dati. However, sa flocculated class, aggregated ang suspension, but upon shaking, nare-redisperse lang siya kaagad. So, somehow, choose your fighter na lang. No? So, you have that. No? So, sa flocculated, nag-aggregate siya, pero madali lang siyang i-shake. Pag shake mo, balik na siya agad sa original. Sa deflocculated, hindi siya aggregated, pero after some time, kung nag-settle na siya, mahirap na siyang ibalik sa well-dispersed suspension. Ayan. Okay. Next. So, ease of redispersibility, no? So, dapat hindi kailangan ng sobrang forceful agitation or pag-shake para lang mag-redisperse, no? So, ease of redispersibility, dapat minimum shaking lang, nare-redisperse na ang ating suspension. And then we have particle size determination. So, particle size determination. So, ideal size, no? Usually, ang ating suspensions class, nasa nasa 5 to 10 micrometer particle size. Okay, tama. Sige. So, ayan, you have your particle size. Kasi 'di ba, pag mas malaki ang particle size, that would mean mas mabigat siya, so mas madali siyang mag-sediment, mag-settle, no? So, ideal size of the of particles for suspension, yan. No, dapat hindi siya masyadong malaki, hindi din masyadong maliit. Kasi either way, pag sobrang maliit, pwede siyang mag-float. And then kung sobra namang malaki, mabilis siyang mag-settle. So, particle size determination, you can use optical microscopy or use the sedimentation rate. Kasi ayun na nga. So, kung mas mabilis siyang mag-settle, mas mabilis ang sedimentation rate, meaning mas malaki yung particle size. So, there for your suspension. Then we have viscosity. So, viscosity, no? So, for your suspension, the viscosity should be optimized na sakto lang siya to be readily or madali lang siyang i-pour, no, from the container. So, di ba, ano nga yung container natin ng suspension? Kung napapansin nyo, no? So, sa mga antibiotics na suspension, they are stored in wide mouth bottles, no? Wide mouth bottles. Bakit sa wide mouth? Because, no, for ease of pouring. Mas madaling i-pour. Dahil medyo viscous si suspension. Pero ayaw natin na sobra siyang viscous na hindi na siya ma-pour, no, from the bottle. So, for viscosity, the basic unit is poids, no? And it is measured by your viscosimeters, no, your Ostwald and your Hubelode viscosimeters or viscometers. Okay, then lastly, we have your zeta potential for your suspensions, no? So when we say zeta potential, the repulsive forces between particles, no? So kung mas ayaw nila sa isa't isa, no? There is greater zeta potential, no? Repulsive, no? So, basically, class, no? Your particles, if they are more attracted to each other, no, mas attracted sila, so madali silang mag-form ng aggregates. So magdikit-dikit sila. So syempre, 'di ba, mas mabigat ito, so mas madali siyang mag-settle. As compared kung very repulsive siya, no? They repel each other, so meaning ayaw nila sa isa't isa, so they will remain separated. So as separated powders or particles, no? So mas magaan sila compared sa dikit-dikit. So since mas magaan sila, no, there is lower settling. Mas magaan, so hindi masyadong mag-settle or mabagal mag-settle. Okay. And we have your temperature and gravitational test or stress test. So ito naman, ito is for the shelf life to determine the stability of your suspension. No, to determine the stability of your suspension. So, i-expose mo yung suspension at high temperature and at high gravity para titingnan mo kung mag-cross ba siya or at high temperature. Okay, next we have your emulsion. So, ito class, very important. Know the different tests and result for each type of emulsion. Okay, so ano ang ating basic principle dito? Ano ang basic principle dito? Ang basic principle is the dispersion medium dictates the property of the emulsion. What do we mean by that? Kung sino yung nasa labas, siya yung magdidictate kung ano yung property. So let's say, dito sa dye solubility, no? Amaranth green, ayan, green yan, amaranth green. Amaranth green is water soluble dye. Palitan ko yung kulay. Is a water soluble dye. So since water soluble siya, ang maggi-green ay yung water ang nasa labas, no? The external phase, the dispersion medium. So green, no? Whereas si Sudan red is an oil soluble dye, no? So para dili makalimutan, no, 'di ba? Si Sudan iprito sa oil, no? So your Sudan red iprito sa oil, oil soluble, and ang mag-red is yung may oil sa gawas, no? Yung oil sa labas. So O, water in oil. Okay? So yun lang yung premise class, no? The dispersion medium will dictate the property or the characteristic of the emulsion. So dito, positive in conduction. Sino ba ang positive in conduction? Si water. Di ba si water, mo conduct siya electricity mo na makakuryente. So, oil in water ang positive for conduction. Fluorescence. Ang positive for fluorescence is the oil. So, sino ang may oil sa labas? No, water in oil. Ayan. Cobalt chloride test. Si cobalt chloride class, pag basa siya, it is pink. No, pag hydrated siya, it is pink. Pag dehydrated or anhydrous, it is blue. So, hydrated siya, nag-come in contact siya with water, so that's oil in water. Nag-come in contact siya with oil, so walang water, anhydrous, so blue, water in oil. Okay? So, pwede class, ang gawin nyo dito, memorize nyo yung isa, tapos lahat ng hindi nyo na-memorize, opposite na. No? So, para dili kayo daghag memorize. No? Save ng space sa utak. So, memorize one side, then whatever you did not memorize or you do not know, no, it's the other side. So, pwede memorize mo si oil in water, the rest na hindi mo alam, water in oil na. Okay? So, ayan. You have your emulsion tests. Okay. So, tests for creaming, cracking, or breaking. Ayan. And phase separation and phase inversion. Sige. So, sino ang reversible? Si creaming or si cracking? Sino ang reversible? Sige. Jessel Del Rosario.
Sa ganito mong balik, reversible po.
O, kinsay reversible? Creaming or cracking?
Creaming po.
Okay. Creaming, no? Pag sinabing creaming, nag-separate lang saglit. Pero, after, tama yun, after agitation, babalik na siya sa pagiging original emulsion. Pero sa cracking or breaking, no, pag sinabi natin broken na ang emulsion, no, that's already irreversible. So, possible na sira na or expired na si emulsion. Okay, so phase separation, then we have phase inversion. So what do we mean by phase inversion? Phase inversion. Kayla, dalagan. Phase inversion. La. Brangel, Luna. Wala. Sige, this will serve as your quiz ha, yung mga hindi natawag. Yun, wala. Okay. Okay, so sa phase inversion, we have, okay, correct, Miss Mission, no? Water in oil, naging oil in water, and vice versa. Okay. Then we have gravitational and temperature stress test. So temperature stress test, so same, no? You subject it to high temperature, and then high extreme pressure from the gravity. So titingnan natin if merong effect on the emulsion. Okay. Next, we have your Likers test for sterile dosage forms, no, for your ampules. Ayan. So, what to remember? We use your negative pressure. Ayan. And the dye that is used is 1% methylene blue. So, anong mangyayari? So, basically, class, ilalagay natin siya sa isang parang chamber. Tapos, andyan yung ating liquor, ang ating ampule. Tapos, ilulublog mo siya sa methylene blue solution. Okay, then apply negative pressure. Afterwards, titingnan mo si ampule kung naging blue ba siya. So, pag naging blue siya, then meaning meron siyang leak. Pero pag hindi, we have a stable or pasa na ampule. No? Walang leaking. Okay. Then we have clarity. So clarity, of course, since ang mga sterile dosage forms are, for example, mga ampule solutions, vials, kailangan i-inject sa directly IV or whatever parenteral administration. So kailangan they have to be clear, no? Walang particles. So it is tested for clarity test. So basically, class, titingnan mo lang talaga kung clear ang solution. Kung may particles ba or wala. So this is 100% human inspection. So wala pang machine dito. No? So titingnan talaga with your eyes. Okay. Next, sterility test. So pag sinabi nating sterile, 'di ba? Walang any microorganism in the product. So we have your sterility test. So first, we can do membrane filtration. So sa membrane filtration class, i-filter mo yung product sa membrane filter, of course. No, pag filter nimo kay product, mabilin diri ang inyong bacteria if ever, and then ito yung i-inoculate mo sa agar or sa any media. Then we have direct inoculation. So sa direct inoculation from your product, yun yung diretso mo straight, no, sa agar. Ayan. So membrane filter, i-filter mo si solution, then yung filter paper, dun ka kukuha na, or sa membrane filter, dun ka kukuha ng sample. Sa direct inoculation, no, for example, lublub mo lang sa solution ang iyong inoculating loop, tapos i-straight mo sa agar. Okay, so saan na media? So for Clostridium, we can use fluid thioglycolate or anaerobic bacteria gamit ng fluid thioglycolate. For strep, we can use soybean casein digest. And for mga broth, the positive result is turbidity. No? Basta turbid, no, this could signal presence of bacteria. Okay. So, test for sterility yon. So, dapat walang nag-grow. Hindi maging turbid ang tawag nito. Ang broth, si agar dapat hindi siya, wala siyang colonies, no? Walang nag-grow dapat. Kasi sterile. No, 'di ba pag sinabi nating sterile, wala ni isang bacteria present. Okay. How about on the sterilization process? No? So, to check if the sterilization process is effective, no, we use this following bacteria. No? So, to check if si autoclave effective talaga, it should kill Bacillus thermophilus. For dry heat, we should use Bacillus subtilis. So, basically, class, isasabay mo to sila sa pag-autoclave. Ito siya. So, dapat, after autoclaving, mamatay na ito. So, kung buhi gihapon siya, class, meaning hindi effective si moist heat or si autoclave. Same goes for ethylene oxide, for radiation. No? So, dapat mamatay itong mga bacteria na ito para masabi mong effective ang sterilization process. Okay? Next, we have bacterial endotoxin test. So, bacterial endotoxin. So, endotoxin, saan nga galing predominantly si endotoxin? Gram positive, gram negative. Endotoxin. Sige, gram positive or gram negative?
Negative ata, ma'am.
Okay, very good, no? So, endotoxin, letter N, no? Gram negative. No? So, sa gram positive, mostly exotoxin. Okay. So, bakit natin kailangan i-test si endotoxin? Bakit kailangan? Ano palang effect, predominant effect ng endotoxins for parenteral or sterile dosage forms?
Kaya lisod siya i-treat, ma'am, like nagdagan siya og kanang protective barrier, si endotoxin.
Okay. Ano yung effect niya? What are the common effects of endotoxin when introduced to the body? Okay, you have fever and chills, to? So usually endotoxins cause fever when introduced to the body. So ayan, or pwede septic shock sa mga mataas na talaga na number of endotoxin. So you have your fever and chills, no? So somehow it is a pyrogen, no? Fever causing substance. So in your bacterial endotoxin test, this is an in vivo, in vitro test, no? Si bacterial endotoxin test, in vivo or in vitro na test. Sige. NJMAC. In vivo or in vitro, si bacterial endotoxin.
In vivo po.
In vivo. Sige. May in vivo ba? Tracy Ipil. Okay. In vitro. 'Di ba? We do this on a test tube. No? So, gamit ang Limulus amebocyte lysate ng horseshoe crab, igagawin mo siya or lalagay mo siya sa test tube. Tapos, you observe the reaction. No? Pag sinabi natin in vitro, outside the body. So, this is an in vitro test. So, the positive result is a gel clot formation. No? So, pag may gel clot, meaning merong presence of endotoxin. Ayan. So, other techniques, other than gel clot, no? So, pwede pa rin turbidimetric, no? So, pag nag-turbid or nag-generate ng color, no? Chromogenic. So, basically, LAL pa rin yung ginamit, pero iba lang yung end result. Okay. How about your pyrogen testing? Pyrogen testing. Shaheen, manipis. Wala. Virdel, Abakahen.
Yes po, ma'am.
Pyrogen test. In vitro, in vivo.
In vivo.
Okay, so it's an in vivo. Okay, in vivo test because we perform it using your rabbits. So we inject your parenteral solution sa rabbits, tapos si rabbit, observe natin kung magkaka-fever. So, since medyo na tayo sa animal cruelty, tapos ayaw na natin gumamit ng rabbits, so we are leaning towards the in vitro, which is yung bacterial endotoxin test. Pero pyrogen test, you have your in vivo, which is using your rabbits. So we use 3 rabbits, mature, healthy rabbits, and then house at the temperature at 20 to 23 degrees Celsius. Okay, so of course, everything should be sterilized, para hindi natin masabi na galing sa mga materials natin yung pyrogen or endotoxin. So dapat sterilized lahat, malinis lahat, and nasa room temperature lahat. Okay, so we check the temperature of the rabbit sa rectum, the rectal temperature. Okay, so si rabbit hindi pa kakainin pero merong water. Okay, so we check the control temperature, meaning bago ka mag-inject ng product, tingnan mo muna ang temperature ni rabbit, So, ayan. So, control temperature should not vary by more than 1 degree Celsius and no temperature should exceed by 39.8. Bakit hindi dapat lumampas ang control temperature ng 39.8? Sa pyrogen testing. So, temperature should not exceed by 39.8. Sige. Diamond, Archie.
I have no idea po.
Okay. Laila, Zakaria. Wala. Sige, may mga sumagot. So, kasi above the normal temp na siya and may fever na siya. Yeah, yes. So, basically, hindi mo na siya pwedeng gamitin kasi in the first place, may fever na siya. So, whatever results na makukuha mo, wrong na. Or affected na. May fever na si rabbit. So, hindi na accurate yung makukuha mong results from the pyrogen testing in the first place. Okay, so using 3 rabbits, inject your product, no, 10 ml per kilogram of the test solution, and then observe the temperature every 30 minutes, no, for the first and 3 hours after injection. So acceptance criteria, dapat walang rabbit na mag-show ng increase ng temperature of 0.5 or greater. No? So, dapat hindi mag-exceed ng 0.5 or hindi maging 0.5. Kung merong nag-0.5, magdagdag ng 5 other rabbits. So, 8 na. No? Diba si 3 sa una. No? Sa 3 rabbit, dapat walang nag-0.5 degrees Celsius increase. Kung meron, then add 5 more. So, sa pag-add ng 5, naging 8 na. So, sa rabbits na 8, dapat walang, hindi lumampas ng 3 ang nag-0.5 increase plus kung i-add mo lahat ng increase in temperature, hindi siya lalagpas ng 3.3. Okay? Take note, naka-end yan. So, dapat both conditions are satisfied. No? Dapat ma-meet niya yung dalawang conditions na yon para masabi mo na pasa siya. Okay, next, safety test. We can do bioassay or cytotoxicity assay using mice or guinea pig or your cells. No? Then we have particulate matter. So presence of extraneous undissolved particles and must be carried out in your laminar airflow environment. No? So your biosafety cabinet. Okay, so for the number of samples, if less than 25 ml ang product, then from 10 units. Pero pa greater than 25 ml ang product, use 1 unit. No? Use individual unit. Okay, so we have different methods. We have method 1, your light obstruction particle count. No? Basically, di ba, pag may particle, mabablock niya yung light. So the number of blockings ng light will tell you the number of particles present. No? So you have your light obstruction particle. So ito ang ating acceptance criteria. Dapat kung greater than 100 ml ang volume, ito yung number of particles na dapat present lang. So kung ganito ang size ng particle, dapat ito yung particles na pwedeng present lang. Pag mas malaki ang particle, mas konti dapat siya. Okay. Yan. Okay, next method, we have your microscopic particle count. So dito, nasa pangalan na using your microscope, no, you count the specific number of particles. So same premise, no, pag mas maliit, pwedeng mas madami. Pero pag mas malaki ang particles, of course, konti ang ating limit. No? Mas konti ang ating tolerance. Okay, so ayan, you have your particle count test. Next, for the environmental control, no, for your sterile area. So we have what we call your clean room or your clean area, sterile area. So dito natin ginagawa yung mga sterile dosage forms. So syempre, para maging sterile sila, dapat sterile din yung environment kung saan sila ginagawa. So we have to control the number of particles na nasa air or nasa surfaces. So to control that, we use your electronic particle counter. So ang nangyayari, class, isasample mo yung air, no? Isasample mo yung air, tapos titingnan mo or ipapakount mo sa electronic particle counter kung ilang particles ang suspended sa air. No? Meron tayong limitation dyan para masabi mong clean ang room or clean room, no? Or sterile area. So, ayan. So, using electronic particle counter class, it can provide size of the particles present and distribution. Pero, hindi siya nakaka-identify ng source at hindi niya ma-differentiate yung air bubbles. So, meaning, kahit yung air bubbles, pwede niyang ma-count as particle. No? So, your electronic particle counter. Okay. Next, checking for your bacteria, no? Sa sterile area. So, di ba sinabi nating sterile, dapat walang bacteria. So, sa air, dapat walang lumulutang na bacteria. So, we use your air sampling device or your slit to agar sampler. So, ang nangyayari dyan, class, no? So, sa room ninyo, sa empty room, may window dyan na close, tapos meron lang slit or opening, no? Sa opening dyan, meron kang agar. So, we call that your row duct plates. I think nasa next slide. Ayan, row duct plates. So, si row duct plates, class, naka-convex ang ating surface of the agar para pagdaan ni air, no, pagdadaan si air dyan, it will come in contact with the agar. So, kung merong bacteria, mag-grow dyan sa agar, no, pag-agi ni air. So, ideally, wala. Kasi, di ba, sterile ang area. So, meaning, ang hangin dyan ay sobrang linis, walang bacteria present. Okay? So, ayan. You have your row duct plates, no? May convex surface, which determines microbes in surface. Roll the lace agar on the surface of flat or regular surfaces to be tested. Then, we have your HEPA filter testing. So, I think familiar naman tayo, no, sa HEPA filter. So, sa HEPA filter class, di ba, your high efficiency particulate air filter. No, 'di ba during pandemic na uso ng HEPA filter or medyo matunog siya sa HEPA filter, no? So it filters the air that comes into you, no? So ang filter membrane, ani class, it's very small that it filters even viruses and bacteria, no? So you have your HEPA filter. So, para ma-check mo kung effective talaga si HEPA filter, we do your bubble point test. No? So, your bubble point test can be using your dioctyl phthalate or si HC Emery. No? So, DOP test or HC Emery test, pareho silang bubble point. No? Pang-test ng effectivity ni HEPA filter. So, si HC Emery 3004 and si dioctyl phthalate class, they are very small particles, no? And titingnan mo kung if it is able to pass through the filter. Kasi kung nakakalusot siya sa filter, then hindi na effective si HEPA filter mo. So, ideally, dapat si DOP or si HC Emery hindi nakaka-pass through sa HEPA filter. Kasi nga, di ba, your HEPA filter, natatanggal niya or nasi-screen out niya lahat ng particles, even including viruses and bacteria. Pero kung nakakalusot na itong dalawa, then your HEPA filter is already damaged or not effective. Okay. So next, we have your packaging material quality control. So discuss lang natin si packaging material. So the first packaging material, we have your glass. No? So gusto natin si glass because it is transparent, no? Very aesthetic, clear, and inert. However, di ba, your glass is made up of alkaline. No? Alkaline treated silicates. So that's your glass, no? Alkaline. So medyo basic, no, si glass. So the basicity or its alkaline tawag nito, alkaline property can cause leaching. What do we mean by leaching, no? So sa leaching class, from the container pupunta sa product. So yung base from the glass pupunta sa product. Whereas absorption, so from the product, ma-absorb ni container. So baliktad lang. Okay, so for type 1, we check for chemical resistance and arsenic content and leaching. No? So again, the alkali from the glass, no, the basic portion of the glass could alter the stability of the product. No? Kasi pwede siyang maging unstable due to different pH. So you have your type 1, 2, and 3, and 4. So type 1 is the highly resistant borosilicate glass. Type 2 is your treated soda lime. And then type 3, soda lime. Then type 4, the non-parenteral, your general purpose soda lime glass. So all of them are tested with powdered glass test except water attack test. No? So water attack specifically for treated soda lime lang siya. No? So basically class, itong mga test na to, these are titration. No? So itatitrate mo yung base kung ma-release from the glass, no, to cause leaching. So first, we have powdered glass test to check the leaching property of crushed glass. No, so literal powdered glass test, no, ika-crush mo yung glass tapos itatitrate mo with an acid. So dapat ang magamit mong titrant is not more than 1 ml for type 1 and for type 3 not more than 8.5. So dapat na-neutralize na siya by less than the said volume of the titrant. Okay. Next, we have your water attack test. No? So leaching property na hindi gi-powder. So leaching property of intact surface, no? Kasi treated soda lime glass. No? So same titrant ang gamit, same indicator. So depende sa volume ang limit, no? So for less than 100 ml, dapat ang magamit na titrant is not more than 0.7. Pag mas madami ang volume, mas konti ang limit mo. No? Not more than 0.2 ml. Okay, then we have surface glass test. So surface glass is tested for type 1 and type 2. No, type 1 and type 2. So the hydrolytic resistance of the inner surface. Ito naman, we use your HCl. No? And the test limit depends on the filling volume. Okay, so titration lang pa rin. Pero ang gamit mo na is HCl, hindi na sulfuric acid. Then we have glass grains test. So si glass grains class, this distinguishes type 1 from the others. No, kasi si type 1 class siya yung pinakakonti ang limit, 0.1. Whereas si type 2 and 3, ang limit natin is 0.85. No? So titration pa rin using HCl and methyl red as the indicator. Okay, so for other testing, no, for type 1, we use arsenic release. Light transmission for mga amber-colored glass, no, mga amber glass containers, dapat, di ba, light, blocking light, no? So protection from light. So dapat hindi siya mag-transmit ng light. Ayan. Surface etching test. Ayan. For high hydrolytic resistance of the inner surface or treatment or chemical composition of glass. Ito naman is, pwede siya for type 2, surface etching. Okay, glass defects, pag sinabi nating crack, no, partial fractures sa heel and sometimes the shoulder of the ampule. Freaks, no, medyo odd, no, 'di ba? Freak, odd ang shape ng glass, kaya hindi na siya pwedeng gamitin. Filaments, no? So parang may gas-gas na hair-like string inside the bottle. So those are our glass defects. Ayan. Then next we have your plastic. So plastic, no? So testing is based whether it is in direct contact of the drug product or kung parenteral siya, no? Kasi kung parenteral ang dosage form, mas strict tayo sa testing sa plastic. Okay, so to test for the type of plastic, we can use IR spectro, differential scanning calorimetry, and heavy metals and non-volatile residue is also tested. Okay, so for parenterals class, no? Kung parenteral ang plastic container, then we use biological reactivity test. Ayan. So, biological reactivity test, pag in vitro, agar diffusion, implantation, or elution test. Pag in vivo, these are the following. No? Systemic injection test using albino mice, intracutaneous test using albino rabbits for plastic containers, eye irritation, albino rabbits pa rin, pero syempre for ophthalmic containers. Implantation test for rabbits, mapa-albino or hindi, for packaging na may direct contact sa tissues. So mga pellets, implants, wafers, no, na i-insert sa skin. Ayan. So you have your packaging, material quality control. Siguro, pero animal cruelty, no? Mostly ngayon naman, naka-in vitro testing na tayo. But there are some testing na mahirap hanapan ng alternative. Kaya in vivo pa rin. But yes, most ay in vitro na. Hopefully, in the future, puro na lang in vitro. Bakit mostly albino pa? Okay. So, sa albino kasi, somehow, mas madaling ma-observe, no? Di ba pag albino, walang melanin, walang pigment sa skin. So, kung may irritation, mas madali mo siyang ma-observe. Di ba puti lang dun siya. So, mas dali niyo makita kung nabunog or may bruise, no? May discoloration. Yon. Pag pigmented kasi or 'di ba pag may melanin o black ang rabbit or black ang rat, mahirap i-observe yung effects. Kung may irritation ba na nangyari or such. Okay. Tapos sa eyes also. Ang albino rice and albino rice, gutom na si ma'am. Albino mice and albino rabbits. Sa eyes nila, wala sila, usually 'di ba ano ang color ng eyes nila? Wala silang color sa eyes. Oo. Oo. Wala sila pigments kaayo sa eyes. So kung naay irritation also, very much observable. Yan. So you have your albino. Sige, last na tayo. Tama ba? Yes, we have your stability testing. So stability study stability testing is one of the functions of a QC analyst. No, tayo yung nagpe-perform dito. You will be practicing as QC pharmacist. No? So to determine when lang stable ang product. So the shelf life of the product. So basically class, no, the shelf life is the time it takes for your drug to reduce by 10%. Meaning 90% na lang yung naiwan. No? So the expiration date is the time in which the active ingredient is more than 90%. So that's manufacturing date plus the shelf life. No? So kasi si shelf life, yan yung number of days, months, or hours na mag-decrease ang inyong drug by 10%. So 90% na lang yung naiwan. Okay, so errors in estimating the expiration date. So type 1, alpha error, too early. So kanino to? Bad for the manufacturer. And then, kung too late naman, of course, bad for the patient. So, dapat sakto lang. Para dili lugi si manufacturer, hindi din ma-poison or ma-toxic si patient. Ayan. So, in stability testing class, we also perform stress test. So, na-discuss na or na-mention natin to kanina, no, kay emulsion tsaka suspension. So by exposing the emulsion or the suspension to high temperature, high gravitational stress, no, somehow na e-expect natin yung stability niya, no? Gaano ba siya ka stable to resist degradation under extreme conditions, no? That is your stress test. So usually ang temperature yung ano natin class, increase and increase para ma-check natin if the stability is okay. Okay, so strictly speaking class, hindi lang sa amount of drug ang basehan dapat ng expiration date. Kasi what if, yes, 90% pa rin yung concentration niya. Pero after 2 years, nag-produce siya na ng toxic product. So, expired na din nun, no? So, hindi lang yung amount ang ating babasehan dapat. So, it should also consider the physical aspect. So, hindi ba siya nag-iba ng kulay, nag-iba ng lasa, nag-iba ng physical properties, no? And also chemical properties, no? Hindi ba siya nag-form ng precipitate, hindi ba siya nag cloudy mixture, ayan. Then microbiological or sterility, nag-grow ba siya ng bacteria or presence of endotoxin, presence of viable microorganisms, no? And toxicity. Ito na yung sinasabi ko kanina. No, kahit pa more than 90% ang concentration, kung nag-produce na siya ng toxic product, no? Toxic metabolite, considered as no na siya, no? Hindi na siya pwede, expired na siya. Okay? Ayan. Okay, ito very important. Ayan, tanong always sa board exam. So, at what climatic conditions does Philippines belong? So, we have zone 4, hot and humid, or the tropical country. Okay, zone 4A and zone 4B. So, we have zone 4B. Okay, so sige. So we have zone 4A and zone 4B. So 4B tayo. Okay. So bakit important ang climate conditions? The stability testing. Bakit important? Sige. Kerubin.
Kasi yung room temperature po natin, ma'am, is different from the others. Medyo like a little bit higher or lower sila. For example, sa Middle East is medyo mainit pa rin. And then sa America or something is medyo malamig talaga yung a little bit malamig yung room temperature po nila. Tapos sa atin kasi, ma'am, is like whole year completely constant po yung room temperature, kaya important po ang zone. Climatic.
Okay. So, yon. Of course, no? So, the storage conditions will depend on the climate, no? So, syempre, mainit ang climate natin. So, our storage conditions are generally higher compared to those sa mga nasa mga temperate conditions. So, yes, no? It will affect the storage condition and, of course, the stability of the drug product. Okay, so we have two types of stability testing. We have long-term or real-time, and we have accelerated. So sa long-term or real-time class, at least 1 to 2 years, no? 1 to 2 years. Sa accelerated, pwede siyang ma-shorten into 6 months. Pero pwede mong i-increase ang temperature para ma-compensate yung shorter amount of time na ginawa for the stability testing. Okay, so these are our storage conditions for real-time stability studies. Ayan, itong 1 and 2. And then we have for accelerated. So as you can see sa accelerated, no, higher ang temperature compared to the real time. No? And then we have stress studies. Same goes for accelerated. No? So tataasan mo yung temperature by 10 para to compensate for the shorter duration of testing. So basically class dito, i-check mo every 3 months year and every 6 months on the second year. Then every year na after. So sa every 3 months class, i-check mo yung concentration niya, yung physical properties niya, lahat ng aspects. Tapos kung merong bumagsak na isa doon, then expired na siya at that time, no? Or yun na yung expiration date. So real time for refrigerated naman. No? So for refrigerated, ayan, 5 degrees Celsius plus minus 3. And then accelerated, syempre mas mataas ang conditions kasi accelerated nga. Okay. So dahil matrabaho ang stability testing, we have reduced study design. So gusto pa rin natin real time, pero problem is sobrang dami ng kailangan na i-study na samples. So first, we can do bracketing. No? So sa bracketing class, extremes lang ang ating iti-test. No? So as you can see dito, no, extremes lang. At the lowest dose, no, 50 milligram dosage strength, and highest dosage strength, 100 milligram. Tapos, ang iti-test mo lang, yung pinakamalaking volume and pinakamaliit. No? So, this is the premise, no, na ang extremes will account for the ones in the middle. No? Meaning, lahat ng extreme, somehow, mako-cover niya na yung nasa middle. So, pwede mo nang hindi i-test yung middle. No? So, yan ang ating bracketing. Extremes are the only ones being tested. So, somehow, nakatipid ka na ng testing. No? Hindi lahat tinetest mo. Then, we have matrixing. So, sa matrixing, we have the following. No? So, una, at first point, i-test mo lahat. After the next time point, half lang yung ite-test mo. So, test mo yung dalawa dito, then isa dito. After the next time point, no, on the next time point, yung hindi mo na-test dito, ite-test mo. Then, alternate. Then, test mo lahat ulit. Test mo selected. Then, yung hindi mo na-test, i-test mo sa next. Then, test mo naman lahat ulit. So, I think you get naman the picture, no? So, somehow, nabawasan pa rin yung burden mo sa pag-test, no? So, test mo lahat muna, then selected na lang. Yung hindi mo na-test, i-test mo siya sa next. Tapos, alternate, then test mo naman lahat ulit, and then alternate. Test mo naman ulit lahat. So, somehow, hindi mo tinest lahat at the same time, but in a way, you still tested it all. No? So, ayan. You have your matrixing. So, in a way, na-reduce pa rin yung burden mo ng pag-test, but well-represented pa rin lahat. No? Na-test pa rin lahat. As compared dito na extremes lang talaga. Okay, so that is our review. So quality is everybody's business. So break a leg in your CEE exam. Ayan. So you have that ends our our lecture for today. Sige. So any
Recording
questions,
stopped.
clarifications for our topic? Sige. So, I think na-upload ang ating Quipper quiz for today. So, ayun, I will, for those na nag-participate fully today, no, that will serve as your oral quiz and perfect score. So, for those na hindi natawag or hindi Oh, pati sa chat, of course. Yung mga tinawag ko tapos hindi nagsagot, then you approach me for your oral quiz. Okay, so I recorded our meeting and also the chat will be saved. No? So lahat ng nag-answer sa chat, then yun na yun. No? That will be your oral recitation. Okay, sige. Sige, para pambawi sa quiz kahapon na okay lang kahit mali. Basta nagsagot. Sige. Okay, sige. That would be all for today. Goodbye, everyone.
Thank you po, ma'am.
Thank you, ma'am.
Thank you, ma'am.